Hi dudes! How are you today? I hope you are doing great. Welcome to another day of learning opportunity. I am your teacher, Mr. Jason Edroda, and I will be discussing with you another topic in automotive servicing. And this is all about the types of electrical circuit in automobile. Electrical components used in recent automobiles employ highly advanced technologies using integrated circuits, and they have become more and more compact and lightweight. In consequence, acquiring that highly advanced knowledge is the urgent necessity for service staff members involved in maintenance of recent automobiles. In practice, however, service work on electrical components is thought to be difficult and seems to be left to specialists in many cases. After learning basics, understanding electrical circuit becomes easy by repeating what you have learned. Well understanding of electrical circuits will enhance learners' skill and will broaden the scope of applying their skills. Before we proceed to our lesson, let us answer first this one. All you have to do is encircle the terminologies that relates to electrical wiring or lighting system in the crossword puzzles. I'll give you 30 seconds to answer. Okay, let's find out what are the terminologies you found in the crossword puzzles. So, here are the terminologies found in the crossword puzzles. Let's find out if you got the correct answer. Number 1, headlight. Number 2, fog lamp. Number 3, signal. Number 4, horn. Number 5, brake. Number 6, circuit. Number 7, tail light. Okay, let's give a hand for those who got the correct answers. Okay, now let's go to our lesson proper. What is a wiring diagram or circuit? Wiring diagram are drawings that show the relationship of electrical components and wires in a circuit. They seldom show the routing of the wires within the electrical system of the vehicle. A wiring diagram or circuit is a simple visual representation of the physical connection and physical layout of an electrical system or circuit. It shows how the electrical wires are interconnected and can also show where fixtures and components may be connected to the system. Okay, I have here a video on the types of automobile wiring circuit. Please watch and listen for you to learn.
This section examines headlight circuits. Bright, well-adjusted headlights are necessary for safe vehicle operation at night. The main beam provides a bright light suitable for driving on open country roads. The dip beam only is used in built-up areas. In country areas, the dip beam is used whenever oncoming traffic could be dazzled by the main beam. The headlight circuit consists of the battery, fusible link and fuses, headlight switch, headlight relays, dipper switch, headlights, high beam indicator light, wiring of a suitable size to carry the electric current through the circuit, and the ground circuit. When the headlights are switched on, current is applied from the battery through the fusible link and fuse across the closed switch contacts to the dipper switch. In the dip beam position, electrical current can flow from the dipper switch contacts through the low beam relay winding to ground. This creates a magnetic field that closes a set of contacts. Closing the contacts allows electrical current to flow from the battery through the fusible link to the relay contact. From the closed relay contacts, the current flows to the light filaments and then to ground. The park and tail lights are also in operation when the headlights are switched on. This section examines the indicator or turn signal circuit. Indicators are amber lights located on the extreme corners of the vehicle. A column-mounted switch, operated by the driver, directs a pulsing current to the indicator lights on one side of the vehicle or the other. These pulsing lights warn other road users of the vehicle's intended change of direction. Once activated, they continue until the switch is cancelled, either by the operator or by a cancelling mechanism in the switch. The cancelling mechanism operates after a turn has been completed and the steering wheel is returned to the straight-ahead position. The circuit consists of the battery, fusible links and fuses, the ignition switch, the flasher unit, a 3-position switch used as the direction indicator switch, the lights at the front and rear of the vehicle, pilot lights mounted in the instrument cluster to indicate to the driver which way the switch has been operated, wiring to connect all of the components, and the ground circuit to return the electrical current to the battery. If the indicator switch is turned to indicate a right-hand turn, current from the battery flows through the fusible link to the ignition switch, where it is directed through a fuse to the flasher unit. The flasher unit uses a timing circuit to pulse the current flowing out of the flasher unit 60 to 120 times per minute. This pulsing current is directed through the indicator switch to the right-hand indicator lights at the front and rear of the vehicle, causing the lamps to flash on and off. A pilot light on the instrument cluster also pulsates. The operation of the flasher unit also produces a clicking sound to warn the driver that the indicators are in operation. When the indicator switch is returned to the off or central position, no current flows through the flasher unit, so the timer circuit is switched off. When the indicator switch is turned in the opposite direction, it directs the pulsing current to the left-hand lights at the front and rear of the vehicle, as well as the left-hand pilot light on the instrument cluster. Most modern vehicles now are equipped with hazard warning lights. This circuit is similar to the indicator lights, except that it simultaneously causes a pulsing in all exterior indicator lights and both pilot lights on the instrument panel. These can warn other road users that a hazardous condition exists, or that the vehicle is standing or parked in a dangerous position on the side of the road. This section examines stoplight circuits. Stoplights are red lights fitted to the rear of the vehicle. They are usually incorporated in the taillight cluster, although many vehicles have a higher additional stoplight mounted on the top of the boot lid or on the rear window called a high-level stop lamp. The stoplights are activated whenever the driver operates the foot brake to slow or to stop the vehicle. The circuit consists of the battery, fusible links and fuses, a stoplight switch, stoplight bulbs, wiring to connect the components, and the ground circuit to return current from the filaments to the battery. When the operator of the vehicle depresses the brake pedal, a switch mounted on the pedal support is closed. This allows electrical current to flow from the battery through the fuse, through the switch, to the brake light filaments, and to return to the battery by the ground system. When the driver releases the pedal, it returns to the rest position and open circuits the stoplight circuit. The flow of electrical current stops and the brake lamps are extinguished. This section examines parking and tail light circuits. For motor vehicles and trailers, 2 red tail lamps operate when the headlight switch is in the park position and the headlight position. The 2 lights are located close to the widest points of the vehicle, so that the vehicle width can be seen by other road users. The bulbs are connected in parallel to each other so that the failure of one filament will not cause total circuit failure. A number plate illumination lamp is usually connected in parallel to the tail lights and operates whenever the tail lights are on. The tail lights are usually incorporated in a cluster assembly at the rear of the vehicle. Government regulations control the height of the lamps and their brightness. The park lights, sometimes called clearance lamps, are located at the front of the vehicle and are used at night time when the vehicle is parked on the side of the road. They use low wattage bulbs and may have a lens or diffuser that makes the emitted light widespread. In some cases, the park lights are incorporated in the headlight assembly. The park lights operate when the light switch is moved to the first position. For safety reasons, the park and tail lights continue to operate when the light switch is moved to the headlight position. The bulbs are connected in parallel with each other. The circuit for the park and tail lights includes the battery, fusible links and fuses, park light switch, the lights at each corner of the vehicle and the number plate light, the wiring to connect the components together, and the ground circuit to complete the circuit to the battery through the vehicle frame. When the park light switch is closed, current flows from the battery through the fusible link to the park light switch, where it is fed through the fuse to the front park lights and to the rear tail and number plate lights. After passing through the filaments, the current path is completed through the frame of the vehicle to the negative battery terminal. This section examines the reversing light circuit. The reversing lights are white lights fitted to the rear of a vehicle. They provide the driver with vision behind the vehicle at night and also alert other drivers to the fact that the vehicle is to be reversed. The circuit consists of the battery, fusible links and fuses, the ignition switch, the reversing light switch on the transmission, reversing light filaments, wiring to connect the components, and the ground circuit to allow current to return to the battery through the vehicle frame. When the ignition switch is on and the vehicle is placed in reverse gear, current flows from the battery through the ignition switch to the closed reversing light switch on the transmission. Electrical current flows across the closed switch to the reversing lights and then returns to the battery by the earth return system.
Okay dudes, did you learn something about the video? So, let's explore now. Complete the drawing of schematic diagram of a horn circuit by connecting terminal of the components. Okay, let's find out to get the correct answer. Congratulations to those who got the correct answers. Okay, now, let's evaluate if you learned something about our topic today. Okay, that's the end of our lesson. I hope that you learned something today. Thank you very much, and until next time, goodbye dudes.